everybody, welcome back to another Miss Pollard Math YouTube video. Today we're going to be going over evaluating functions using our function notation. So first it's important to know what is a function. So a function is when none of the x values repeat. So we get a set of points, that's when our x's, we look at them, they cannot repeat, or primarily what we're going to be focusing on today is graphs, and we look at the graph, and we're going to use the vertical line test. We do a vertical line at every section on the graph. It can only hit once. So if I draw a vertical line, it can only hit our graph once. If it hits more than once, it's not a function. So every single equation we're given today is a function, and that's what we're going to be working with. We also have to look at the key points of our function notation to know what it means and how to apply it. So for example, we have f of x. This means f of x. This does not mean f times x or g times x. This means f of x. So we have f of x, g of x, h of x. Any letter of x denotes that this equation following the equal sign is a function. So other times we're just given y equals. But if we do y equals, that doesn't have to be a function on the other side of the equal sign. So when it's denoted f of x equals g of x equals, that means it is a function. So a lot of the times they'll say, create a function. You have to write it as f of x. It's saying it is a function, f of x, g of x, whatever variable it asks you to do. So what are we learning here? F of x, g of x, h of x denotes it's a function, but more importantly is the same thing as y equals. So when we did our evaluating expressions in our prior grades where we were plugging in values for each, that's exactly what we're doing here. All the changes, the denotation, and the way that we're writing it with f of x, g of x, and so on and so forth. So let's look at a practice problem and see how we would apply this. So we're going to discuss what f of -4 equals 9 means, because you're like, wait, am I multiplying f by -4? No, once again, that is saying f of x technically equals 9. The -4 is on the inside. So if we look, this is usually f of x, right? We saw before, it's f of x. Inside that parentheses is the x, right? So that's what that's saying here. In here it's saying that my x is -4. So this is saying x is -4. We saw before that isn't f of x the same thing as y? So we're saying that f of x, when my x is -4, equals 9. Well, if f of x equals 9, that's the same thing as y, so y equals 9. So we are saying when our x is -4 or y is 9, and we can write that as an ordered pair. That ordered pair would be -4, 9. If your teacher asks you, of course, every time you're not going to write the ordered pair, but if they said give this as an ordered pair, obviously write it like that. So this is what it's saying. The number inside the parentheses is your x value. The number on the other side of the equal sign is your y value. Let's take a look at a problem where we're thoroughly discussing how to do this. So let's try some practice problems. We're given g of x equals -3x squared plus 2x minus 7, and h of x equals 9x minus 4. So we are going to look. I have g of -2. I'm going to plug that into my g of x equation. I'm not going to plug it into my h of x equation, right? Those are not equitable. Those are not the same. So I need to plug it in. G of -2. We saw before that the number inside the parentheses is our x value. So it's x equals -2. I'm going to plug that in for my x values. So I get -3 times -2 squared plus 2 times -2 minus 7. Now I'm going to evaluate that just like I did in the past where I evaluated expressions. Now we're just stepping it up a notch and writing the answer in a different way, or writing the question in a different way. So I have to use my order of operations, my PEMDAS. I'm going to use my exponents first. So I do -2 squared, which is 4, times -3 is -12. So I square it first. -2 times -2 is 4, times -3 is -12. 2 times -2 is -4, minus 7, and then I add them up together. -12 minus 4 is -16, minus 7 is -23. I'm not just going to write my answer as -23 though. I need to write it in proper function notation. What is -23? Well, when my x is -2, my y is -3, but I'm going to write that in the proper notation we just saw. So I'm going to write g of -2. When my x is -2, my answer is -23. So -2, -23. We're going to do this now, but with our h. I have h of 2. I'm not going to plug it into the g of x. I'm going to plug it into the h of x. So I get, this is my x value. So I get 9 times 2, because it's 9x, minus 4. 9 times 2 is 18. Minus 4 gives me 14. And once again, I have to write this in proper function notation. So when my x value for my h function is 2, my y, or my h of x, is 14. And that would be my final answer. One more problem like that. Once again, the number inside the parentheses means our x value is that value. So my x is 1/3. So I'm going to plug that in. 9 to the h value, right? H of 1/3, h of x. So 9, plug it in for x, times 1/3 minus 4. 9 times 1/3 is 3, minus 4 gives me -1. So h of 1/3 equals -1. So those are the ways that we do this problem if we are given our value inside the parentheses. Inside the parentheses means that's our x value. Now let's look at something like this. We have h of x equals 23. So that means in other terms, our y is 23, or really our h of x is 23. That's what we're working with. That's the form we're denoting. So h of x equals 23. So instead of h of x, here, I'm going to use the 23. So no more h of x, it's 23. I'm substituting it in. So I get 23 equals 9x minus 4. I add 4, add 4. So I get 27 equals 9x. I divide by 9, and I get x equals 3. So my x value is 3 when my h of x is 23. So I have to rewrite that. I write h of 3 equals 23. And that would be my final answer. So I got my x is 3. I have to plug it into where my x value goes, which is right here. Let's take a look at another problem of a different way that we can do this using a graph, a table. Let's see what to do. So now we're giving a table, and we want to look. We have f of 8. Like before, we saw this is when our x equals 8. So I look, my x values. My x equals 8 right here. When my x equals 8, my y equals 4. So I'm going to say f of 8 when my x is 8 equals 4. We're going to look over here. My f of x equals -4. That's when my y is -4. So I'm going to look, where is my y? -4. Right here. And my x value is 6. So f of 6 equals -4 is my final answer. Let's take a look at when we are given a graph and how we would complete that. So now I'm given this graph, and I'm given f of -1. So this is when my x equals -1. When my x is -1, I look, and I have to look where the graph is. The graph is down here, and I look right here. When my x is -1, my y is -2. So I have f of -1 equals -2. We're just following the graph and seeing my x value is -1. Well, where is it on the graph? At -2. Let's do the same thing now, but instead we have f of x equals 1. So that's when my y equals 1. Well, my y is 1 here. So I can draw in the line to see. So I'm hitting 1, 2, 3. So I'm going to have 3 answers, which is okay. You could have a million answers. I got 3 answers. So I get f of -2 equals 1. I get f of 0 equals 1. And I get f of 2 equals 1. So all 3 answers are correct. My x value here is -2. My x value here is 0. My x value here is 2. So -2, 0, 1. All 3 of these points cross when my y is 1 on that graph. Finally, let's take a look of when I'm giving you a solution. You have to see, is it truly a solution or not? So we are asked, is this a solution? If not, give a solution that works. So this point here is -3, 9. I'm given the equation, -5x plus 4. I need to see if this is a solution. So I'm going to plug in that x value. And I'm going to see, when I plug in that x value, do I get a y of 9? So I get -5 times -3 plus 4. -5 times -3 is 15. Plus 4 gives me 19. Is that 19? No, that's 9. So this is not a solution. So I'm going to say not a solution. However, it asks if it's not a solution to give a solution that works. I personally think the easiest solution to work with is when our x is 0. So I'm going to plug in 0 for x and see what our y becomes. So I get our h of x becomes. I get negative 5 times 0 plus 4. This becomes 0. This stays at 4. So I would say not a solution, but f of 0 equals 4 is. And some of my students say, well, why can't I just use negative 3's answer? When I plugged in negative 3, I got 19. Why can't I use that? Well, what if you made a mistake? What if you said negative times a negative was still a negative and you got the wrong answer? Then you're going to get the wrong answer on this problem. So I like to use the safe one by plugging 0 in. When you plug 0 in, you get 4. And that is a solution. So I hope this was helpful to determine how to evaluate functions using function notation.